Dear students, in the previous class, we studied about composition of functions and invertible functions and solved some problems with respect to that. Today, we shall solve some problem on invertible functions. That is 5-mark questions in your annual question paper. There are 5 questions, I think 5 problems only in your book. You practice that. I will solve that problems and explain the steps involved in that solving that problem. Invertible. I take one problem. Consider f is a function from R to R given by f of x equal to 4x plus 3. Show that f is invertible. Find the inverse of f. Yeah. Consider f is a function from R to R, means real number to real number. Domain also real number, range also. Given by codomain also R. But f of x equal to function is 4x plus 3. Show that f is invertible. Find the inverse of f. Here, first we show this function is invertible. Here, we can follow 2 methods. One is the function is 1 1 and onto, then the function is 1 and 1 2, then it is invertible. Then find the inverse of f. Another is we take y is a element from range. We select y from y. You search pre-image in x. Pre-image in x means domain. We choose y, an element of codomain, then search pre-image in x with respect to y. If then f naught g and g naught f of x and f naught g of y. It's an identity of x and it also identity of y. Then it is invertible. Here we select any arbitrary element in y range from range. We find the pre-image in x. Then define g function. Then define g function from there. Then find G naught F or G composition of X and F composition of G, then find F inverse of the function. First we solve one method. First method. An arbitrary element y belongs to y. It's a domain range of f. Y is a range of f. Function is f of x equal to 4x plus 3. Then let y is equal to means f of x equal to y. You already know about the function. If it is x, it is f of x. Here x equal to 1. 1 into 4. 4 plus 3 is 7. It's the f of x. Domain is the elements of R. And range is f of x with respect to the elements of the domain. Here we select y here. We find the pre-image in this. Therefore, y is equal to 4x plus 3. We find x value. 4x plus 3 is equal to y. 4x is equal to y minus 3. Then x equal to y minus 3 by 4, which is belongs to R or x with respect to that y. Y is an image or arbitrary element in codomain. Then find the respective x in the domain is y minus 3 divided by 4 is the element. This is the image. Then x is equal to y minus 3 by 4. Then we define the function. Another function, it is the function g is a function from R to R. Here, invertible function is f is from R to R, then g is a function from R to R. Reverse. Then g is equal to or g of y. Here g of f of x. Here g of y is equal to y minus 3 by 4 means x. G of y is equal to x, but x is equal to y minus 3 by 4. It's the difference. First, you find the arbitrary, you take any arbitrary element in y and find respective x in domain. Then define the function g from R to R and g of y is equal to y minus 3 by 4. Then find g naught f of x, which is equal to g of f of x is 4x plus 3, which is equal to, in g function, we substitute this in y is equal to 4x plus 3. G is equal to 4x plus 3 minus 3 divided by 4. 3 gets cancelled. 4 also gets cancelled. Then it is equal to x. That is equal to Ix. Then find
G f of f composition of g of y, which is equal to f composition of g of y is equal to f of g of y, which is equal to f of g of y is equal to y minus 3 divided by 4. Here we put the value here in the x. 4 y minus 3 divided by 4 plus 3. Here 4 gets cancelled. Y minus 3 plus 3 is equal to y. F composition of g of y is equal to y is equal to I1. We get the identity of x here, Ix. Put the x here, we get the x, and g of y is equal to y, that is the identity of y. Then f naught g is gets Iy, and g of f of x gets Ix. Then we find its the function is invertible. The function is function f of x is invertible with g. Then f inverse is equal to g, or f inverse of x is equal to x minus 3 divided by 4, or f inverse y is equal to y minus 3 by 4. First, I once again repeat these steps because it's a 5-mark question. If you not define this one, you lose 1 or 2 marks. Therefore, first you choose an arbitrary element y belongs to y, and y is equal to 4x plus 3, and find the value of x, means the pre-image of y. Then you define the function g from R to R. If it is S to N, then you write it as N to S. It's a reversal. Then g of y is equal to y minus 3 divided by 4. Then find g naught f of x, means g composition of f and f composition of g. You find, if you put x here, you get x. If you put y, you get y. Here also f of f naught f of composition of g of y, you get y. Then the function f of x is invertible with g of y. Then f inverse is equal to g. You also here also you know they are right. If you write f inverse of x, you write x minus 0 by 4. And f inverse y is equal to y minus 3 by 4, because you choose y, you get the pre-image y minus 3 by 4 here. Y minus 3 by 4 is y, and if it is x, here the pre-image is x minus 3 by 4. You remember this one, then you always write f inverse of x is equal to x minus 3 by 4, and f inverse y is equal to y minus 3 by 4 with respect to this problem. It's the one method. Another is alternate method is also there. In that method, you first the functions will be 1 1 and 1 2. Therefore, first you prove the function is 1 1 and 1 2. Then
it's invertible. Then we find g of y minus 3 divided by 4 is equal to x y. Then only you write it as a quadratic function. Then you write inverse of I solve that method also the same problem. You already know about proving the one function and onto function alternatively. Let x1, x2 belongs to R, means range of domain of F. Here we choose x1, x2 from domain of F. It's R. F of x1 is equal to f of x2. F of x1 is equal to 4x1 plus 3 is equal to 4x2 plus 3. Then 4x1 is equal to 4x2, 3 gets cancelled. x1 is equal to x2. Therefore, f is 1, 1. You already know about this. Then on to function, we choose an arbitrary like y is equal to arbitrary element y from codomain or range y is equal to 4x plus 3. Then x equal to y minus 3 by 4. I already you know about this one, which is belongs to R. It is belongs to R. Then y is from belongs to range of F. Range of F. Y is equal to 4x plus 3. Then x is equal to y minus 3 by 4. Then f of y minus 3 divided by 4, which is equal to f of y minus 3 by 4 is equal to 1, because we put here f of y minus 3 is equal to 4 into y minus 3 divided by 4. 4 gets cancelled, plus 3. 4 gets cancelled. Then y minus 3 plus 3 is equal to 1. Therefore, f of y minus 3 by 4 is equal to y, means every element of range or codomain of F, every element of codomain of F, there exists an image, pre-image in X domain. Every element of Y, there will exist an pre-image in X. Therefore, the function is 1. That is on. Therefore, function is 1, and onto. Therefore, f is invertible. Then you find the f inverse is equal to f inverse y, f inverse is equal to g, or f inverse is equal to y minus 3 is equal by 4, or f inverse x is equal to x minus 3 by 4. Anyone you can write here. These two, anyone you have to write. Not two f inverse y and f inverse x. F inverse y or and f inverse x you can write it.
In this method is very easy method because you already know about one function, proving the one function and one-to function. This also very easy, but sometimes you forgot to write this one. Which one is this one? If you don't write this one and define if it's 1, 1, 1, 2 and 1, 1, these are small mistakes you can done, then you lose some marks. Therefore, you practice one method and perfect about that and solving this problem. You know about all of this, but you sometimes forgot to write some. Sometimes you forgot to write f inverse of x or 1, 1 or 1, 2. These steps, all steps include 1, 1 mark. Here it is 1 mark, it's also 1 mark, it's also 1 mark. Then it's 1 mark 4. Then it's also 1 mark. Then 5 marks. 1, 1 function, onto function, and proving that the function is invertible. The function is invertible. Then find the inverse of f. Here, one more problem I will do that one in the one method only. Another method, you try yourself. Let f is a function from n to r, be a function defined as f of x equal to 4x square plus 12x plus 15. Show that f is a function from n to s, where s is the range of f and f is invertible. Find inverse of f. Find inverse of f. F is a function from n to r, be a function defined as f of x equal to 4x square plus 12x plus 15. Show that f is a function from n to s, where s is the range of f. F is invertible and find inverse of f. I find the invertible proved by first method. Here, let y is belongs to y. Y here is s, an arbitrary element. Then y is equal to 4x square plus 12x plus 15. Here, this type of problem is a quadratic equation. We find x is very difficult, therefore we made it perfect square. It's not a perfect square. I do perfect square by first element, first 4x square is there, 2x square. Then the second element is 2 into 2x into 2 into 2 4, it's a 12. 2 into 2 4, 4 into 3 is 12. I write it as is the a square plus 2ab plus b square form. 2x whole square plus 2 times 2x into 3. Here it is 3. Then we third element is here 3 square. We add 3 square because b square is there. Therefore, 2x whole square plus 2 into 2x plus into 3 plus 3 square. We added the 3 square, then I subtract 3 square plus 15. For perfect square, I add 3 square. Therefore, I subtract 3 square plus 15. We get 2x plus 3 whole square. Here 9 minus 9 plus 15. It's equal to 15 minus 6. Minus 9 is 6 plus 6. Then here 6 becomes here. Y minus 6 divided y minus 6 is equal to 2x plus 3. Then square root of y minus 6 is equal to 2x plus 3, taking square root both sides. Here 6 this side, then we take square root both sides, getting root of y minus 6 equal to 2x plus 3, then root of y minus 6 minus 3 is equal to 2x, then root of y minus 6 minus 3 divided by 2 is equal to x. Therefore, x equal to root of y minus 6 minus 3. It's not in the square root. Square root is only for y minus 6. Then minus 3 divided by 2 is x. It's the free image in y. In x, free image for y. Therefore, x equal to y minus 6 square root of y minus 6 minus 3 divided by 2. Then we define g function. G is a function from s to n. S to n. Because here it is n to s. Then it is s to n by g of y, which is equal to root of y minus 6 minus 3 divided by 2. Understand? G is a function from, here n is a function from n to s. It's a function from, g is a function from s to n. Then g of y is equal to root of y minus 6 minus 3 divided by 2. Then find G composition of f of x, which is equal to, we put this in the g function. G f of x is 4x square plus 12x plus 3, but we put 2x plus 3 whole square plus 6. It's the same. It is equal to, in the g, we substitute g is in y is equal to 2x plus 3 whole square plus 6 minus 6. It's in the square root. See here, g of 2x plus 3 whole square plus 6 is y. It's a y. We substitute in y 2x plus 3 whole square plus 6 minus 6 minus 3 divided by 2, which is equal to 6 cancel, square root. It's square root of square 2x plus 3 whole square, taking square root, which is equal to 2x plus 3. 2x plus 3 minus 3 divided by 2, which is equal to x. Is equal to x. Then we find f naught g, or f composition of g of y, which is equal to, we put f g is y minus 6 minus 3 divided by 2. We put this one in 2x plus 3 whole square, 2 into x equal to root y minus 6 minus 3 divided by 2 whole square. 2x whole square here, 2 into x means y minus 6 minus 3 divided by 2. Then 2x plus 3 whole square plus 6. Here 2x is 2 cancel. Then root of minus 6 minus 3, it's a plus 3. If this one is cancelled, perfect square, which is equal to root of minus 6 is y, y minus 6 plus 6, which is equal to 1. It's cancelled. Yeah, root of y minus 6 minus 3 divided by 2, 2 gets cancelled. Then root of y minus 6 minus 3 plus 3, it's 3 cancelled. Then it's a perfect square. Square root and perfect square is gets y minus 6 plus 6. We get y, which is equal to y. Here ix. Therefore, f naught g of y is equal to iy and g naught f of x equal to ix. Therefore, identity function. Therefore, the function is invertible. Therefore, the function is f is invertible with g. Therefore, f inverse is equal to g. Then f inverse is equal to x. F inverse of x equal to root of x minus 6 minus 3 divided by 2. If it's y, y minus 6 minus 3 divided by 2 is the lengthy problem. This one is the solved problem also. I once again recall this problem. Another 3 more problems are there. You solve yourself only. You like first method, you will use that only. If you like second method, you practice that. Don't practice 2 methods and confusion. Confusion is there. Therefore, you always practice 1 method. Then we go to the binary operations. Binary operation. What is binary operation? Binary means by means 2. Binary operation means it's 2. I think you do not study this binary operations. Binary operation. Here binary. Here A and a binary operation is a function. It's a one of the function star. It's denoted by binary operation is like star on a set A is a function. It's a function. Binary operation star on a set A typically is a function star from A cross A to A. Means star is an operation from ordered pair. It is a cross product of A. Cross product of A to A. Which one will given here? AB is a product is an element of A cross A. Then you get A star B. You get something. It belongs to A. Belongs to A. This is the binary operation. Yeah, binary operation. By means two elements operation. Which type star on a set A. A is a set, some elements are there. 1, 2, 3, something. It's a function star from A cross A to A. Means it's A. Then A cross A is equal to 1, 1, 1, 2, etc. Then star is a function from A cross A to A. A means here A cross A is this one. Here A is the set 1, 2, 3, etc. It belongs to this set. Then only it's a binary operation. If we take any ordered pair, then make the operation star. Operation star may be plus, minus, or input, or division, etc. Then only we find another element which should be in the A set. Then only we call it as a binary operation. Here, within addition, multiplication, and subtraction on R means plus means A star B. Here A plus B for all AB belongs to R. A plus B belongs to means it is equal to C, which belongs to R itself. Then A star B belongs to A minus B, which is equal to another element B, which belongs to R. Then AB belongs to R. A into B, it's also E, it belongs to R. These belongs to R. Then only we call it as a binary operation. But in the division is not a binary operation on R, because here in the division 0 is there in the R set. R is including 0 also, but 1 by 0 is not defined. 1 by 0 is not defined. Therefore 1 by 0 is not belongs to R. Therefore division is not a binary operation on R. But if we remove the R, it's a R star. It's non-zero real number. It's a non-zero real number. Then R star is a binary operation on division also. Division is a binary operation. Division is a binary operation on R star, which is non-zero real number set. Here once again conclude this definition. Sometimes asked in 1 mark question also.
In the 2 mark questions, define binary operation and some problems are given. Prove that it's a binary operation. One star operation is given. Show that
Star from Z to Z. Z cross Z to Z. Defined by A star B is equal to AB plus 1. For all AB belongs to Z. Is it binary operation? Is it binary operation? First we take for all AB belongs to Z, then A star B is equal to AB plus 1. Here multiplication of Z is a binary operation. A into B, we take any element of Z, we get element in Z only. Therefore AB is a binary operation. Then AB plus 1, adding 1 plus that a product of AB, we get that 1 is also belongs to Z. We take an example, 2 and 3 are belongs to Z, then 2 plus 3, 2 star 3 is equal to 2 plus 2 into 3 plus 1, it's equal to 6 plus 1. You take any element of Z, you can operation, take binary operation, that 2 element, we get the element is belongs to Z itself. Therefore, it's a binary operation. Therefore, star is a binary operation. If any element is not belongs to Z, then it is not a binary operation. If it is AB by A by B, star is a function from A star B is equal to A by B, then A star B is equal to A by B is not belongs to Z because 2 is belongs to Z. 1 by 2, 1 star 2, which is equal to 1 by 2 is not belongs to Z. Not belongs to Z because Z is a set of integers. It's not an including rational numbers. Therefore, it's not a binary operation. Like this, you can do some problem. The star operation, after star operation, getting the element is belongs to Z. Next we know the properties of binary operations. Thank you. Sarvandra.